this is the task for the Reverse Engineering International competition. So the module is Reverse Engineering from a Physical Model. This is the piece just here. Now in the international competition, this physical piece will be given to each competitor. As you've downloaded this from the Autodesk website, we've actually put this completed part in there for you. One of the things you can do is 3D print it and have a go at measuring it yourself. Of course that won't be as accurate because it won't be machined, and it depends on the quality of your 3D printer, but by all means have a go at doing that. So moving on, I'll talk as if this were the competition where you have the actual piece. So the module is Reverse Engineering from a Physical Model. The time you're given is 6 hours from start to finish. And you will be given just the physical model, and that's it. So the scenario is that your company has received permission from the parent company to manufacture and sell parts under license. First step in the process is to reverse engineer a specific part, which is the part you've seen on the front page. So the task, after you've reviewed the part, you measure, sketch and model the part and produce a drawing of it. The physical component will be removed after 2 hours. You will then have a further 4 hours to complete the project. So in the international competition, you will be given the physical part, which looks like this, which is a cast part of aluminium, and after 2 hours it will be taken away. So you have 2 hours to get as much information off of that piece as possible by measuring it using the tools you have available to you. So some people start modelling straight away, and then in the last hour they then start doing sketches of the bits they haven't got to model yet. Some people just spend 2 hours doing paper sketches, so it's completely up to you how you spend your time. So task 1, you need to sketch and model the part. So like I said, if required you can create sketches on paper, that's not a problem. And then you need to use the following information to assist with the measurement process. So the measuring accuracy is plus or minus 0.2 mil when measuring across 2 machine surfaces, and plus or minus half a mil when measuring unfinished surfaces. Radii and chamfers of 0.4 mil or less are not required. Neglect any surface irregularity. So if the part's been dropped and there's a chip taken out of it, then of course you ignore that part. Review the part, instructions and illustrations. See note 1 for features that are modified or do not have to be modelled. Assume 1.5 degree draft angle where required. Review the attached sketches for dimensions. See note 2, so it'll be down at the bottom. 3. Create the model of the part and save the part using the competition file naming convention. Then task 2, you'll need to create the drawing. On the first sheet, create 4 shaded isometric views to display the major features of the part. Machined surfaces should be machined aluminium in appearance. The cast surfaces should be aluminium cast in appearance. So if you go to the selective task for this, it shows you how to differ between cast and machined in the model. Number 2, on the second sheet, create a detailed drawing of the part. To complete the drawing, all annotations and styles must meet ISO standards and dimension as required for manufacture. All main dimensions should be placed using 1 decimal place. You will need to apply GDT and add surface texture symbols. Add a note listing the volume of the part in millimeters cubed. You will then need to create a rendered image using Inventor Studio and save the file using the competition file naming conventions. So the outputs: software model part, a drawing file and rendered image. Of course, with this downloaded task from the Autodesk website, you'll have the model part there already, but it'll be a good idea to try and model it yourself in your own technique. And then note 1, all drawing sheets should be printed on an A3. And note 2 is all files are to be saved to a folder on your desktop which is named with your full name. You've then got the marking scheme, so the presence of the part features, so ensuring all the part features are there. So that'll be the holes and the flanges and the tapped holes. You'll get 12 marks for that, which is a large part, which of course you're not going to be able to get from downloading this, but well, in essence you'll already have all those 12 marks because you have the software model part. You then get 8.25 marks for dimensions, 0.75 for the tolerances including GDT, and 0.75 for the surfaces, and 3.25 for the presentation. So the presentation will be the drawing and also for your rendered image. And going down, there's this appendix note here, so it's just showing these parts are closed. So some of the physical models may have had discrepancies there, so it's just clarifying that it's closed up at these areas, and it's also giving you the dimension between chamber 1 and chamber 2. And that is the task for reverse engineering.